Hi everyone, my name is Xinran Hu, and today I'm going to share my project. My project is Geospatial Logical Pine-Site Index Modeling from Climate Parameters in Alberta. First, let's talk something about the background. What is the site index? The site index is the top height at an index age, usually age 50 in the northern forest in Alberta, and we can see here is an example of the Douglas fir site index. If the Douglas fir is 50 years old and the top height is 80 feet, then the site index is 80. So another question is why it is valuable to do geospatial site index modeling. It is because if we want to get the site index, we need to go to the plots and measuring the tree age and the tree height. But sometimes some plots are very difficult for humans to access and for measuring. So if we want to know the site index of everywhere in Alberta, the geospatial site index modeling will be very valuable. So the objective of my project is exploring the relationship between logical point site index and the climate variables, do the geospatial site index modeling by random forest method using the climate data of 2095 plus, and predicting logical point site index using the climate data of the whole Alberta. First, let's see my data table for analysis. It includes the plot, the location, the site index, and other climate variables. So this is based on the 2095 plots I already have. And here is another data table for the prediction using the random forest model. It only have the location of the plots and the new climate data. So this locations comes from the Alberta shapefile and the DEM Alberta file. I extract the coordinates of the whole Alberta and then extract the new climate data. Here is a map shows my sample plots. There are almost 2095 plots, and they are all located near the Rocky Mountain. Here is my data exploration. First, this is the figure about the plot site index distribution. Seems like it is a normal distribution. To make the climate data less skewed and outliers less extreme, it is necessary to do the data transformation. So this can bring the data closer to the normal distribution. So we can see that the first row and the third row show the original data of the climate variables distribution, and the second row and the fourth row shows the data after the transformation. After the data transformation, I did the PCA analysis of my climate variables and the plot site index. The plot site index is presented as these different color dots, and we can find from this PCA that in this direction, the PAS, the DD.5, and the NFFD, the FFP, MWMT, AHM, these climate variables are almost in the same directions with the plot site index. So, like these climate variables are positive correlated with the cluster 4, and these climate variables are negative correlated with the class 4. And then I also did a heat map based on the correlation matrix between the site index and the climate variables. We can find that the result is almost the same to the PCA analysis, like the MWMT, the FFP, and the HM both show the strongly correlation with the plot site index. And we can find that the strongest prediction of site index are almost all measure of the heat. After that, I used the random forest method to do the modeling. We can find that the MSP, PAS, and the DD.5 are the most important predictors of the modeling. And here is the summary of my modeling, like we can see that the mean of square residues is 5.23, and the percentage variance explained is 47.23. So it shows that my modeling is have the high accuracy and can be used to predict the site index. Finally, I used the level plot to draw a map of the whole Alberta of the range of the site index of the longitudinal pi, and based on the different climate variables. Like I put all the new location and the new climate variables into the modeling, and finally I got the new site index, and we can find that in the Rocky Mountain, the site index is not very high, but in the blue part, the site index is very high. So my conclusion is, first, the MWMTH, MDD.5, and other three climate variables are among the most important predictors, and the random forest model provides a reasonable level of prediction accuracy for site index in the given dataset. So next step, I will try to use the future climate data to predict future longitudinal pi site index and try to find other ways to improve the model accuracy. Thank you for listening.